Hey, Ignite Crew, welcome back. Here we go. We're going to have a good day. Today, Saturn, one of the most incredible, beautiful planets there is out there. And I will say this, no telescope needed, backyard astronomer. If you have even a small telescope or a pair of binoculars, one of the most impressive things you can see on your own without any super fancy equipment is the rings of Saturn. You will see that there is a sphere, and then you can just barely make out the elongation of the rings depending on where Saturn is in its orbit. And other than the moon, the mountains, and the craters on the moon, it's probably the most interesting, unique thing you can find with really, really basic equipment in your own yard. Okay, here we go. Saturn goes around the sun. Saturn has not been around the sun since you have been born. Not really even close. It takes 30 years, 29 and a half years for Saturn to go around the sun. Well, what that means is that the rings, Saturn's tilted even more than Earth, a little bit. All right, Earth, Mars, Saturn all have a high 20-degree incline. So that means over here, 1987, we were seeing the North Pole and all of Saturn's north, and then you cross and you get the equator in line. Because remember, if this takes 30 years all the way around, this is 15. So it's 7 years to here. So if it's 7 years to here, Earth's going to do a quick lap, and this is going to be perfectly lined up right there. All right, so 2003, 2010, so 10 years later, 2020, we're over here. We're seeing the northern half of Saturn again. All right. But this is what the difference would be from the equator, from the end on, to seeing the southern hemisphere as you go from here, 95, through the into early 2000. So that's the difference in appearance of Saturn from Earth. All right. A lot like Jupiter. There are layers of atmosphere. They rotate fast. They have differential rotation. There's a strong magnetic field, not as strong as Jupiter's. Let's see. Because Saturn has a crazy low density. If you could come up with a bathtub big enough, Saturn would float. It's less dense than water. That tells us that Saturn is mostly hydrogen and helium. So is everything in astronomy. Hydrogen and helium, 92.4% hydrogen, 7.4% helium. That's a little different. We'll come back to that later. Methane and ammonia make up your fractions, the biggest fractions of what's left on Saturn. Here we go. Big picture. 9.5 times the mass of Earth. Okay. Pause. We're going to pause here. I think I've got something wrong. Nothing wrong. I just couldn't read my notes here. 95 times the mass of Earth and 9.5 times the radius of Earth. All right. The density is less than that of water, so it's way less than that of Earth. We already mentioned that. All right. So here we go. Let's look at some cool pictures of Saturn. That's a pretty cool picture of Saturn. All right, here we go. Again, 0 degrees altitude or zero. There is no solid surface. Saturn is another gas giant. There is no solid surface anywhere on there. But 0 altitude is what we're going to say is the top of the troposphere. Top of the troposphere. Got me there. It's where the weather happens. The troposphere is where the weather happens. So we've got the haze coming down below. We've got layers of ammonia ice, ammonium hydrosulfide ice, and water ice. Temperature and pressure increase as you move down into the interior of the planet. Remember, that just means that the cloud layers are getting thicker, the pressure is going up, but there's no solid anything as you move down. Okay? All right. This is a false color image, but this enhances and shows you the differential rotation. You've got east-west winds blowing in layers, not nearly as pronounced as on Jupiter. The other thing is the wind speed is way off to one side. Everybody's wanting to blow wind to the east. very little westward wind movement, but you still have regions where the wind's blowing strong to the east and then the wind blows strong to the west right next to each other near the poles. Near the equator, everything, there's this big wide band. You can barely see it underlaid on this photo of everything running to the east. Okay. Heat and rotation. All right. Heat on Saturn is different. Saturn gives off more energy than it gets from the sun. So the question is, what's going on? This is not a core. When that says metallic, it does not. Metallic hydrogen is just a form of hydrogen. All right. Pressure increases, pressure increases, pressure increases. We can get to liquid states. We can get to molten metals, but we do not have a solid surface anywhere on Saturn. Saturn gives off more heat than it receives because of what it's made of. I said that helium was only 7%. Most other things, Jupiter was 14%, different things, should be less hydrogen, more helium. Should go from 7 to 14% of helium. Well, here's the thing. Saturn's chemical composition, early on, the helium dissolved in the upper atmosphere, and then it rained down, and it fell very slowly. Well, that turns gravitational potential energy into kinetic energy, which heats the interior core, which has slowly been leaking that energy back out into space, even more than it's absorbing for the sun. So the chemical reactions dissolve the helium. Helium falls to the core, which is why it's only 7% helium up on the cloud layers. And then that helium, that as it falls, gains heat energy and is slowly released back out. All right. The magnetic field is strong. It's weaker than Jupiter. Okay. That was 9. 11. Galileo, the first one. Those are aurora. That's in the ultraviolet. That's fine. Galileo was the first guy to see Saturn. That's what he drew. He drew figure A back in 1610. He also drew figure B 6 years later. This is what he saw with his primitive telescope. Figure C was Christian Huygens, Dutch or Danish astronomer. He drew that in 1655. That's how long we've known Saturn has had rings. And when I say you don't need fancy telescopes, if they could do it in 1600 with 2 polished lenses, a pair of binoculars can probably get you to that kind of resolution of Saturn. Okay? So let's talk about these rings. It's not one ring. It's a system of rings, and scientists are really pretty boring. There's A ring, B ring, C ring, D ring, E ring. The Cassini division, that's an old astronomer that they thought it was just inside and outside. There was one giant gap, and then later they found the Inky gap, and then on and on. Then we realized there's all these little things. Very, very thin, okay? Very, very thin. 10, 15 meters, okay? 10 to 15 meters thick. That's all this is. And it is reflective. So the rings are very reflective. They're incredibly thin, like 10, 20, 30 meters thin, height of a building thin, but they're 200,000 kilometers across. The difference is they're so thin when we see Saturn edge on twice every 30 years, right? That they almost disappear entirely. It's very, very thin, very, very crazy to see what's going on. All right. How do we get these rings? What's going on? The Roche limit. Okay. Roche limit is a mathematical number. It's 2.5 times this, 2.4 times the size of the planet. If something comes in nearby, basically, if you get closer than that line, the gravity holding your little moon together is weaker than the gravity attracting you to the planet. And so it starts to stretch and deform the rock until it breaks apart into all these little bitty icy chunks. It is very reflective, very thin, and the Roche limit is here. Let's look at this other photo. This is scaled. This is not the same distance. So this is planet radius. So this is the radius of Jupiter and then 2 times the radius of Jupiter. Well, Saturn is smaller, but this is the radius of Saturn and 2 times the radius of Saturn. All 4 of the gas giants have rings, and all of the rings fit within the Roche limit. All right, scientists like A, B, C, D, E, F here. Then we've got Greek alphabet here, and then these have names, and Jupiter just has 1. So those are the rings. Let's get one more good picture here. We've got what happens when the satellite crosses over on the other side of the sun. You get this weird backlit look. There are several in this series where Cassini stayed around Saturn, and there are lots of pictures from Cassini satellite and Saturn. The sun is on the other side, lighting up all these rings. That's why those are glowing bright. They're not reflecting light. Well, they're reflecting light in amongst themselves, but the light is glowing there. Saturn is dark because the sun's on the other side. The whole thing is backlit. This is a really weird perspective, and it's a really great shot. Okay? All right. The moons of Saturn are kind of crazy. All right. Saturn, again, has dozens of moons, but unlike Jupiter has large moons, Io, Europa, Ganymede, and Callisto, and it's got tiny little rocks. Saturn has large moons. Saturn has mid-size and tiny little rocks. But we're first and foremost going to talk about Titan. Titan is Saturn's largest moon. It's the second largest moon in all of the solar system, behind Europa. Yeah. We got lots of cuts today in this. I said Europa and then I paused. It's because it's Ganymede. Io, Europa, Ganymede, and Callisto go around Jupiter. All right? Io's volcanoes. Europa is water ice. Ganymede is the biggest, and its twin in style is Callisto. Ganymede's the biggest. It's bigger than Mercury. Titan is around Saturn. Titan is larger than Mercury. Titan is larger than Mercury. Titan has plate tectonics. There are Titan quakes happening on the moon. All right. There are. Let's see. We can come down here. Let's get some good pictures. Titan's got a lot going on for it. So this 24C, that is from the surface of Titan. This is the Huygens probe. Titan is cold. It's so cold that water ice, acts like rock. There's no chance of it thawing and doing anything else. It is rock hard. It is frozen, and that is the surface. In fact, anytime there's weird stuff going on, water comes up as a geyser or a volcano. Water would be the magma, and it's eroding and changing the landscape as it comes up and moves out and refreezes. But what's really going on? Titan has liquids on its surface. It's the only other place besides Earth in the solar system that has liquids on its surface. It is not water. It is methane. In fact, it has a methane cycle. There's methane rain. There are methane rivers, methane lakes, methane evaporation, methane rain, methane rivers, methane evaporation. There's a methane cycle. It's so cold, the methane can be liquid. It is absolutely wild to see what happens there. There it is. This is in radio. This is not true color, but there's a lake, there's a lake, there's a lake, there's a pond, there's a lake, there's a pond. That is liquid methane on the surface of Titan. It is absolutely crazy. There's a lot. Some scientists think that, hey, it's got water, it's got this cycle, it might be habitable. We'll let You decide. We'll figure that out. This is Titan. This is not Saturn. This is Titan. Silica core, high pressure ice. Like I said, it acts like the rocks. A little bit of liquid water. Surface, cold, icy surface. All right. Here are a bunch of the mid-sized moons. Here's Earth's moon. So you have a whole bunch of mid-sized moons that Jupiter doesn't have, but Saturn does. Okay. Last thing, this one's kind of interesting. I want to show you co-orbital moons. Co-orbital moons, meaning they have the same orbit. How can two things be in the same place at the same time? They're not. There are things like big moons and then like little rocks that will trail in the exact same path the big moon is taken. That happens. And mathematically, there are fancy Lagrangian points. Lagrange was a French mathematician. There are special points where you could put a rock here, a rock here, a rock here, and they all just make a nice little circle and nobody bothers each other. That happens. These two moons, Janus and Epimetheus. Sorry, I can't speak today. I'm having a rough day, so it's okay. Here they go. Moon 1A and Moon 2 at A. The inner moon's going to orbit faster, so it's going to lap it. It takes 4 years after they cross. They're going to lap, and as this one gets close and starts to pass, gravity from the two moons pull, and they pull on each other, and they flip spots so that the outer moon gets pulled and the inner moon gets pulled, and they cross, and then the inner moon is closer to Saturn. So it's going to take 4 years to orbit around, and then it's going to flip spots again. That's a weird little dance, and no one's really sure how or why it happened, but Saturn's pretty cool, okay? Lots of rings, similar flow patterns, cloud layers to Jupiter. Titan's got all sorts of features. Ignite students, let's finish this one up. Have a great day.